think the simplest way of graphing equations is by graphing their x and y intercepts. So I'm first going to introduce the x and y intercepts. An x-intercept is where the graph crosses the x-axis. The y-intercept is where the graph crosses the y-axis. To find the x-intercept, we let y equal 0 and solve for x. So we're going to do this in this first example, and this is when we just have a regular equation. We have an x in there, we have a y in there, and nothing else. So we let y equal 0, and of course when y equals 0, that y term will just go away because 0 times anything is 0. So that just leaves us with 3x equals 15, and that reduces back down to solving linear equations. We've got 3 times x, so we divide by 3, and that gives us x equals 5. And that's our ordered pair, 5, 0. And when we're graphing our point, we start at the origin. The first number tells us to go to the right or to the left. We have a positive 5, so we move 5 places to the right. 1, 2, 3, 4, 5. And the 0 tells us to stay where we're at. The second number tells you to go up or down. Since it's 0, we don't go up or down. And that's our point. Now to graph an equation, we need two ordered pairs. We need 2 points. So we're then going to find the y-intercept by letting x equal 0. When we let x equal 0, that is going to make our x term go away, leaving us with 5y equal 15. And when we divide by 5, that leaves us with y equal 3. So our ordered pair is 0, 3. Starting at the origin again, 0 tells us that we do not move to the left or to the right. The second number, 3, tells us to go up 3 units, 1, 2, 3, and graph our point. Now that we have 2 points, we draw a line through our 2 points. And that is our graph of the equation 3x plus 5y equals 15. The second type of example I want to go over, because I know in the past classes the majority of the students has missed this. And this second example, y equals the absolute value of x plus 3. We need to go back and remind ourselves what absolute value means. This means that the absolute value of x is when x is always positive. Now there's 2 possible cases for this. Y equals a positive x plus 3 when x is greater than 0. It can also be y equal negative x plus 3 when x is less than 0. Okay, so what's going to happen here is our graph is going to look like a V. And to find our graph, the x and y intercepts don't really apply here when we have the absolute value. So the best thing to do is set up our table of values and plug in numbers for x and find what y is going to be. We have 2 parts of this graph. It's going to look like one graph when x is greater than 0 and something different when x is less than 0. So we need to make sure to pick a point that's less than 0. We can use one where x is equal to 0 and another one when x is greater than 0. When x is negative 1, that means that x is less than 0, so we need to use the second graph. So when x is equal to negative 1, y is equal to 4. And we're running out of time in this video, so I will continue with this in the next video.